All right, now we're recording. Okay. So, so for this problem, how many degree of freedom is it? Step one, right? Find out if it's chapter 16, chapter 17. Step one, find the degree of freedom. The answer is 2. Why is it 2? Can something move? Yeah? Okay. You know, these things slide back and forth. I guess I should be doing this, huh? This guy here can slide back and forth, right? He's kind of on rollers and he slides back and forth. Okay, stop him, count 1 and stop him. He can't move anymore, okay? Can anything move? Well, this guy up here can move back and forth, right? He stays horizontal, he's not tipping. Yeah, how do you know that? Well, okay, I'm just telling you, they're not tipping, okay? So they're both kind of going horizontal. Okay, those are gears. So what happens is here are the notches in my fingers and here are the notches on my fingers, and they go like this, they back and forth. Right. How gears work.
So that's why I don't understand if B's not moving.
Okay, if B doesn't move, okay, then this guy up here can go back and forth and this guy rolls.
Oh, gotcha.
Got it? Okay, and if it's hard for you to see the orange guys going, look at the blue guy. Okay, what I'm going to do is I'm going to say, okay, the orange on the bottom can move. Okay, let's hold him still. Well, then now you can rotate this gear, right, and roll him along the bottom, and the top gear goes with him.
I thought A was fixed.
No, A's not fixed, but you know. Now, you know, it's difficult. I understand it's difficult, and if you notice in your textbook, they don't talk about degree of freedom, because they consider it an advanced topic. Now the problem is, I'm not trying to teach you to solve textbook problems, right? I mean, yeah, you got to do that. I understand that. You got to do that in order to pass the class and in order to get a degree. But I'm really more concerned about what are you going to do once you have your degree. And I'm assuming, and you'll probably all say, ain't no way that's going to happen. I'm assuming that you're going to try to work in an area that's related to dynamics, right? And if you say no, I don't care, I'm going to get you ready to work in an area with dynamics. And they're not going to pay you to do textbook problems. Now, when that happens, you'll be able to see where the pinion is connected, and you'll be able to tell you know whether or not it's pinned down at the center. You'll go look at it. You see? So, shoot. Right? So you'll know whether it's pinned down in the center, okay? The other thing I'll be happy to do is if on a test you look at that thing and you say, I think it's pinned down at the center, raise your hand and say, is it pinned down at the center? No, it isn't. Now, I won't say what's the degree of freedom. I won't tell you that, right? But I'll tell you it's pinned down, it's not pinned down. This is moving, that's not moving. And it's best to look at the problem first, look through there and go, yeah, I get it, I know, right? So that I can tell everybody what it's doing, okay? So, is everybody comfortable that it's 2 degrees of freedom? Okay. Now, when you count the degree of freedom, sometimes when you start on the bottom gear, and that might get you confused, start on another gear and see if you know you get a different. It should be the same no matter how you count it. So what will happen, like for example, if you say, okay, I'm going to hold gear A. Okay, think about holding gear A. Can gear A move? Yes. Okay, hold it. And that means hold one thing. What is one thing that the gear could be doing? Here's what you're going to do. I'll bet you anything. What you're going to do is you're going to go like this. I'm going to hold this gear right here. And you're going to stop it from rotating, right? And then I'm going to say, okay, 1 degree of freedom. Now, can anything move? And what do you say? Doesn't look like it, does it? But gear A is not pinned down, is it? Can't I slide it back and forth? 2 degrees of freedom. Okay, stop it from going back and forth. You can't let it rotate and you can't let it go back and forth. Those are your 2 freedoms. Can anything move? Not unless you shear off gear teeth. Got it? So it's still, no matter how you count it, it's 2. But maybe that confuses you. So start on the bottom gear. Bless you. Doesn't matter where you start, you should come up to the same. And if you're confused, start on the top, count it, start on the bottom, count it, start in the pinion, count it, It's 2 degrees of freedom. Is everybody okay with the fact that it's 2 degrees of freedom? Okay, step 1. What does 2 degrees of freedom mean? If you're given 2 positions, you can find any other position you want. If you're given 2 single dot terms, you can find any other single dot term. If you're given 2 accelerations, 2 double dot terms, they don't have to be full accelerations, but 2 things that have double dots on them, you can find all the other double dots. That's what 2 degree of freedom means, okay? By the way, when you take system dynamics, the book does talk about degree of freedom, so I'm getting you ready for the next course, okay? All right, so what am I given? I'm given 2 single dot terms. I'm given 2 velocities. That means I can find any double dot term you want, right? Any double dot term that you want. What is it I want? Angular velocity. And the velocity of the center. Okay, those are 2 dot terms. Thank God they only asked me for 2, right? Because then I couldn't do it, could I? No, that's not true. You can find any single dot term you want. Any single dot term you want. Doggone it. Right? You can find 22 single dot terms if you want 22 of them. Got the idea? So it's not important that it asks you for this one and this one. That's not what's important. What's important is it's only asking you for dot terms. You got it? Okay. That's why they have to give me 2 speeds. See how it all matches up? They have to give me 2 speeds or I can't solve it until I get to chapter 17. Does it make sense? Okay. So if this shows up on an exam, you should be able to say this is a chapter 16 problem, not a chapter 17. Okay? All right. Okay, so how are we going to do it? Well, what are the methods that we know, that you know, to solve chapter 16 problems? Loops. Okay, loops are good. What do loops do? They relate. They're for relationships. They'll relate one dot to another. Hey, that's what I'm doing. Okay, so that's in the running. What else do we, bless you, what else do we have? We have some chapter 12 stuff. Remember that? X equals x0 plus blah, blah. Is this a time spanner? Okay, then those aren't going to do me any good. What else did we have? Ropes. You got any ropes in here? No. Now, there are things that are similar to ropes, and you can use those as well. They're very similar to loops. Okay, so we have loops, we have ropes. Loops sounds like a good option, perhaps. Let's see. The other one is the special points, this thing, the omega R stuff, right? We have that one. That's chapter 16. You can bet which way we're going to go, right? Chapter 16 stuff, right? The omega R. I call them special points. Okay, let's see. You can also write the position of something differentiated a couple times. You can do that. So how many different things do we have? It looks to me like I got 4. So you wanted a second point, write it down. Okay, what are you going to do? You're going, if it's a motion problem, you've got 4 possibilities, it sounds like, that you could apply to this problem. What do I like to do? If I can use a loop, I like to use a loop. Why? Because I use Mathematica and I don't worry about the differentiation. Man, that's easy. I just let it do it, okay? The downside of loops is if you can't see the loop, it's mind-boggling. Do you see a loop in there? Ouch. Okay, so I'm going to try and avoid the loops. Not that I can't do it, it's just that, man, I think I'm going to get confused trying to write it down. Get the idea? Okay, so what am I going to use? I'm going to use special points. The other rule of thumb, it's not Newton's law, right? I'm nowhere close to Newton. Another rule of thumb, that means it usually works, is if you have a lot of temporary contact, use special points. It usually is the easiest, less mind-boggling way to do it. Okay? So I'm going to use special points. Ready? Okay. Here come the steps for special points. You only use the equations for special points. What's a special point? There's 3 reasons a point is special. What are they? Put these in your notes because you're going to ask me for them. What 3 reasons make a point special? You want to know something about it. I don't care what order you do them in. You want to know something about it. You do know something about it. Touching more than one body. Okay, how many special points do you have in this problem? Okay, good reading, right? How do you know what they are? Show me where they are. And they're labeled, okay? Right? This point B at the bottom, that is glued down, it's painted on, it's a red spot, it's a black spot on the gear. It doesn't move. When the gear, well, excuse me, when the gear moves, it moves. Dang, gummit. Come on. Almost got this technology down. Almost, man. Okay. When the rack moves, B moves. You got it? Okay. C. Tell me about C. Why is C special? You know something about it. It's painted on the top rack. When the rack moves, it moves. What is its velocity? Since you say you know something about it, what is it? It's 4, and it's to the left, because they told me that, right? There's another reason that C is special. It only has to have one reason. It's in contact. It's in what kind of contact? Is it always in contact? Temporary contact, right? Because as the thing moves, it's going to roll away, right? So it's in temporary contact. Is it slipping or not? Those are gear teeth. Slipping is like this, you know, like this. I don't know how that's going to come out in the video, but right? This is slip. Is it doing that? No. Okay, so it's temporary contact, no slip. Right? We had a table that describes that, and I'll put it on the notes here. Okay, so the temporary contact, no slip. Why is P special? I know only one reason why P is special. Okay, but you're jumping ahead. I would say it's special because it touches more than one body. That's why I would say it's special, but you're right, okay, because you're thinking about the table, right? Okay, so I'd say P is special, okay? Why is Q special? And by the way, P is a dot on the pinion gear. So when the pinion gear moves, it's going to move away. So it's in temporary contact, no slip. Got it? Okay. Why is Q special? For the same reason. It's touching two bodies. Okay? And what kind of contact is it? Temporary contact, no slip. Got it? There's one more point that's special. Why is it special? A, because you want to know something about it. I would say, well, it's also special because you do know something about it. What do you know about it? I'm not sure about that, but you know it has a zero vertical velocity. I don't need that, by the way. But can you notice that it has a zero vertical velocity? Is it going up and down? No, it's just going to go side to side. So you could say, oh, he's special because I know a little bit about him. That would bring him in to where you say, that's some information I could use to solve this problem. I may or may not need it. You got the idea? Okay, so there are 5 special points. I don't see any others. Do you? Okay, so I see 5 special points. Now, the rule of thumb says, how many equations are you going to write? Put this in your notes. Rule of thumb. How many equations are you going to write? 4. Why 4? It's always one less than the number of points. Why? Because if you write 5 equations, what you'll find is the 5th one is dependent on the others. So if you write these 4 and combine them in some way, you'll get the 5th one. Okay, it'll happen every time. Does it mean you have to have all 4? No, sometimes you get lucky and you can solve the problem in 2. Okay? I don't worry about getting lucky. I just get fast at writing the 4 equations. Okay? That's what I do. I just get fast at it and say, I'm going to write 4 and I'm going to pick up some partial credit. Got it? And then whether you have to solve all 4, that's a different matter. Got it? Okay. So there's 4 equations. Okay. Shall we start? What do you know about P? Temporary contact, no slip. Okay. I promised you I'd write the draw the table on here. So let me put a table on here. Oops, let's see. Let me find room for a table. Okay. Table goes over here. Let's see. Get my black pen. Okay, so there the types of contact. You have permanent contact. And we have, let's see. velocity in the normal. We'll just say velocity, and we have acceleration. Okay, if you have permanent contact between 2 points, what can you say about the velocity? They're the same. What can you say? In all directions, they're the same. What can you say about the acceleration? Same, right? Because they're going together. They're always together. So what one's doing, the other guy's doing. Have to. Otherwise, they're going to separate, right? So this is the same. Okay, you have temporary contact, no slip. That's the other type of contact you can have. Okay, and remember, on contact, there's a normal and a plane direction. Do you need a review on what the normal and the plane directions are? Okay, let's say here's one guy that's touching. Man, I can't hold my hand still. Man, it makes it look like use your imagination, okay? And so here's a point over here that's touching and a point that's over here touching, okay? Each of these bodies will have a center of curvature. They will, okay? So let's say there's a center of curvature, there's a center of curvature. If you if you draw a line through the centers of curvature, they will always pass through the point of contact. Even if one guy is flat, it'll always do that, okay? And if you don't believe it, go to NX and you try to draw something that, where the center of curvature, and draw the line, and I dare you, just try to do it. It can't happen. That line that I just drew is called the normal. The other direction is called the plane. I call it the plane. Some people call it I don't know what they call it. I call it the plane because it's actually two directions in there. We're only doing 2D contact, or we're only doing 2D problems in this class, but in 3D, there are two other directions, okay? They form a plane, so I call it the plane direction, okay? So I'm going to call that the normal. I'm going to call this the plane. Use your imagination. Got it? So that's your normal, that's your plane. Okay, now, what can you tell me about temporary contact, no slip, the velocities? Are they in all directions? Absolutely. What can you say about the accelerations? Here you have to be careful. They're not all the same. They're only the same in one direction. In the plane. Same in the plane. And actually, if you're in 3 dimensions, that's 2 directions. It'll be the same in 2 directions if it's 3-dimensional problem, right? But since we're not doing 3D problems, it's same in 1 direction. Why isn't it the same in the normal? Well, what happens if you think about something rolling on something else, that point that's in contact has to let go. It's got to let go. Otherwise, it's in permanent contact and it'll stay there and it won't roll, right? That's the definition. It's got to lift off of the incline. Now, if it's not doing this, right, if it's not slipping, then it can't be accelerating that way. So what does it do? It lifts vertically up. I know it's hard to believe, but it'll lift vertically up. As soon as it breaks contact, then it'll take off and do whatever it feels like. Okay? So what's going to happen is if you have temporary contact with no slip, nothing can be happening in the plane. What it will do is it'll lift vertically up, accelerate up, until it breaks contact, and then it's going to do whatever. You have no idea what it's doing. Okay, so it will accelerate vertically away from, I say vertical, whatever is the normal direction, they're going to separate this way, and then they'll spin. They don't go far. They just break contact, and then boom, somebody else is in contact. Okay, that's mind-boggling. That's the way it works. I'll bring you in a demo. Okay, what about temporary contact with slip? We haven't seen that yet. Can you tell me anything about the velocities? Same in what direction? In the normal. Same in normal. They will be different in the plane. That's what slip means, because they're doing this. That's what slip means. Got it? So in the plane, they've got to be different or else there's no slip. Okay. What can you say about the acceleration? They're probably different in all directions. No idea what they're doing. Got it? So that's the table. Okay, we have temporary contact, no slip. We're looking at velocities. What can you tell me about the velocities of the points that are in temporary contact, no slip? They're the same. Okay? So up here I'm going to write 4 equations, right? VP equals VC. Why is VP equal to VC? Temporary contact, no slip. Got it? Okay, so VP equals VC. That's equation number 1. What is the velocity of C?
4 meters per second.
-4. Right? It's 4. What direction? To the left. I always take my eye to the right. Why? Because I forget what I do, and so I do it always the same so that, you know, it's always the same. So I is to the right, J is up. It's the way I'm always going to do it. And if I don't, I will tell you. So if I don't tell you which way is which, I is a pretty good bet it's going to be to the right. All right, so it's a -4I. Anybody have an issue with that? Okay. What's the next equation I write? I've got 3 left, right? So let's do P and Q. Why do I write these in this order? It doesn't matter. I'm going to write 4. Okay, just whichever, right? Between the 5 points, you're going to pick 4, and off you go. Okay? So this one seemed like an easy one to me, so I wrote it. VQ equals VB. Right? Why? Temporary contact, no slip. You see how boring these problems are? I mean, if you do it the way I'm teaching, now you don't have to. You don't have to. Because when I started my career, I didn't do it this way. Right? I just did it hook by crook, man, and good luck. Okay? So anyway, and why is it 8? Why is it +8? +8I. It's going to the right, a value of 8. Would it freak you out if it was going left at 8? Some of you are going, yeah. Some of you are going, no. Those of you that are going, no, good. Okay, those of you that are going, yeah, watch out. Okay, exams could be, if this were on an exam, I might try to freak you out, make it go to the left. Does it matter? No, you just put in a -8I. So what? So what? You got it? Who cares? So what? Okay, what's the next equation I write? It's this one right here, right? Let's see, and make sure I got my highlighter on. Here's the highlighter. That was the first equation. That one was easy. Second equation. Okay, here comes the third one. Tell me about that. What's special about that? First of all, what 2 points did I pick? A and Q? Why A and Q? Why not P and Q? I don't know. Would it work if I used P and Q? Yeah. In fact, I do it the next one, right? Yeah, you got to pick 2, right? You could have picked B and A. B and A. That's dumb, right? And the reason it's dumb is because they're on 2 different bodies. Now, it turns out that B and Q are the same stinking thing in this problem. But what if it was temporary contact without slip or with slip? Ay. Man, that's a little harder, you see? So what I do is I pick, if I can, I try to pick points that are on the body together, except when they have that temporary contact type of thing. And then I wrote those. You see what I'm saying, right? So this guy up here, this one here, those 2 points are not on the body together, but I'm using the special point, you know, the contact. You see that? All of the other points I'm going to pick are going to be on the same body. Why do I do that? It's because if they're doing something wild and crazy, you don't want these 2 things on different bodies, because now you got to also keep in mind the contact stuff. That's hard. So if you say, okay, look, I'm just going to try to write all of my points with the omega r stuff, pick the points on the same body, and then there's less going on in your head. Does it make sense? Right? In this case, it didn't matter. I could have done either way. You got it? But it's because it's a real simple problem. Yeah, you have a question.
Yeah, one quick question. On the point 3, how do you know it's not negative point 3?
Oh, here? Okay, good question. Let's figure that out. So he's asking about this guy right here. Okay, and let's talk about that. But first of all, you see, why did I pick A and Q? I don't know. I could have chosen P and Q. In fact, I did that next time. Why Q and A? Oh, it could have been P and A. It's just pick 2 points on the body, right? There's 3 of them on that body. I'm going to have 2 equations. Pick them. Don't waste your time like I'm doing, right? Pick them. Okay, A and Q. Why did I put A on the left and instead of Q? Doesn't matter. It does not matter. Okay, it can go either way. Take your pick. The only reason in my mind I put A on the left is the problem asked me what's the velocity of A. So I want velocity of A equals. So I have something that says this is equal to that. Boom. It's easier to solve, I think, than if I shoved it over there on the right. Does it matter? No. Will I take off? No. Okay? Will not take off. So we got A and Q. So what you do when you're writing this special point, you say, okay, I chose the A, so I write VA equals, right? Here's the pattern right there. It's always the same. Any 2 points equals velocity of Q. That's why I put a Q there. Got it? What is this omega? Of what body? It's got to be of a body. Why A? Because that's where the 2 points are. Well, it's the pinion. Better be careful because A is a point, right? Points don't have angular velocity. It's the pinion. Why? Because the 2 points are on the pinion. It's the omega of the pinion. Turns out it can be any omega. Don't do that. It'll blow your mind because there's an equation that does it. If the 2 points are in the same body, this is the equation. So it's the omega of the pinion. No question about it. Omega of the pinion. Okay, what is this R? This R has to be R from where to where? From here to here. How do I know? Because it's from the guy on the right to the guy on the left. From the right to the left. Now, here's how your book writes it. They write it as A/Q. Whoops, that's supposed to be a Q, but right, okay. There's a little problem with the technology. A/Q. Okay, here's how I remember it. I think of that as a fraction. Okay? So what I do is I know that's not multiplied. This is just what I do to remember. Okay? The Q is on the bottom, and I've got a Q on the top. The Q on the top divided by a Q gives me nothing. Gives me 1, right? And what am I left with? A, which matches this guy. You remember it any way you want. Sometimes people will write it like this, which I think is better. R, and they'll write Q, arrow, A. That's okay with me too. And that way you know that it's going from Q to A. You get that? But it's got to go from this guy, whatever you choose. You can choose whichever one you want. Once you choose them, it's got to go from the right guy to the left guy. Otherwise, you'll have the wrong sign.
So if it was VP equals VA, it would be a negative 3?
That's right. If I had written VQ equals VA, this would have been negative 0.3J. Okay? See how mindless this is? So I expect hundreds on the next exam. If I got it? Okay, or you're on your own. Okay, you don't have to do it my way. All right? I'm just giving you 30 years of experience. That's it. Okay, so why is it a positive 0.3J? Because I'm going from Q to A. And which way is that? Up. How far? 0.3. You see how easy it is? You just have to remember it's right to the left. Always right to left. Then you'll be okay. Okay. Tell me about that next equation. That's 3. Got 3 out of 4 down. Why did I pick P and Q? The only reason I did it was because I know something about P and I know something about Q, so there's fewer unknowns in that equation. That's the only reason that I did it. Could you have gone from P to A? Absolutely. Could you go from A to P? Oh, absolutely. Makes absolutely no difference. Just pick one. I chose P and Q because I know more about P and Q than I do about A. That's the only reason. Okay, so here we go. Why did I pick P first? Didn't matter. I thought, well, P comes in the alphabet before Q. Okay, fine, P. Makes no difference. Pick one, okay? Velocity of P equals velocity of Q plus omega. What omega? The pinion. Why the pinion? Because the 2 points are on the pinion. This guy's only got one guy rotating. If you had more than one body rotating, you got to know which one. Is it this one, that one, or the other one? You pick the guy that the 2 points are on. That's what you do, okay? So it's omega of the pinion. It's the same one as the omega before. Why is it 0.6J? Goes from Q to P. So you're there and you go straight up. Why is it 0.6? It's all the way across. Why is it J? Because it's up. Okay? Boom, you just picked up a whole bunch of points. Yeah, I say that too. Oh, all right, man. Okay, so now what? Now you solve. Okay, so here's what I did. I solve them. I come in and, okay, you follow the blue arrow. What did I do for the blue arrow?
Oh, you
Plugged in VQ. I mean, all it is, at this point, go to Mathematica, and say, you solve it. It's just solving equations. That's all we're going to do. Do it any way you know how. This is what it looked easy to me. I said, oh, I know what Q is. It's 8. So I put in 8. Make sure you put in the directions, because if you just put in 8, you'll get confused. That 8 goes horizontally, right? It doesn't add to a J. I assume you know that from statics, right? Okay, you can't add an I and a J. They don't add together, okay? So 8I. I don't care what you call it, and I don't care if you put bars over it. That's up to you, right? Some people are nitpickers. I don't care, but you better make sure you remember it's a horizontal. You can write it 8H if you want to, 8 horizontal. I don't care. Just make sure you know it's a horizontal one. Okay. Why did I put omega, a number, omega, in a K?
So when it's multiplied with the J, it becomes an I?
No, that's not why, but that's what it'll do. But why do I put it in omega? Huh? Yeah, use your right-hand rule. You see they've already drawn what positive omega is. They say counterclockwise is what they are going to call positive omega. You see that on the diagram? It's right, let's see, I'll get my highlighter. Come on, baby. Come on. There we go. Okay. So right here, all that work just to highlight that thing, right? See that? Okay, take your right hand, curl your fingers in a natural way. Make them line up with that arrow, that rotation. Which way is your thumb pointing? More or less. Out of the paper, right? Okay, that is what I'm calling positive K. I is to the right, J is up, K is out. So that is a positive K. That's why I write omega K. If they had put the arrowhead clockwise, what would you do? Curl your fingers of your right hand in a natural way, kind of line them up. Maybe you have to do a body contortion or whatever, but line them up in the direction of clockwise. And which way is your thumb pointing? Inward. That would be a negative omega K. Got it? I would write negative omega K. If I solve for omega and get a negative number, what would that mean to me? I just drew it wrong. It doesn't go the way they drew it. Which way does it go? Clockwise. Got it? Okay, now, about 25% of you are going to be taking your exam. You're right-handed. You'll be taking your exam and you'll be doing this. The left-hand rule does not work. It gets you negative, 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 negative. Okay, don't do this. Put your pencil down and go like this and then write. Okay? I think Newton must have been left-handed. Right? Because he could write like this and he'd be going, no, I'm just kidding. Okay. That didn't go over so hot. Yeah, he's rolling over right now. Okay, so that's why I put in positive omega K. Right? So all I did was I plugged numbers in. And then what do I do? What's the next step? What's the next blue step? I just did the cross product. How do you know that K cross J is a minus I? Remember the thing I showed you? I'll draw it in over here. Yeah, what you do is you come in here and you do, let's see, you write I. You do it any way you want. Here's an I, here's a J, here's a K. And then you draw positive this way. Okay, and I'm doing K cross J. So you start with the K. So you start here at K, and you go to J, and that gives you an I. So the answer is an I. Did I go clockwise to do that, or or did I go positive to do it, or negative to do it? Negative. So it's a negative I. If you remember something that they taught you in statics that works for you, do it. I don't care how you do it, but you need to know that K cross J is minus I. Memorize it if you have to, right? Whatever, okay? So that's how I know that that's a negative I. Now the way I do cross products, I pull the omega out, I pull the 0.3 out, then I do the cross product. And if there's a negative in there, I bring the negative with the number. Okay, so if that was, for example, here, let me show you. If you had something like this, minus 3K cross minus 2I. Okay, here's what I would do. I'd say that's a negative 3 times a negative 2, and then I'd say, what's K cross I? Positive or negative? Positive. Then I'd say like this, positive J. What's the answer? Positive 6J. Get it? You do it any way you want. That's the way I do it because I get confused saying K cross negative J. What? So I pull the negative out front with the numbers. Got it? You do anything you want, but that's the way I do it to make sure I don't make a stupid mistake. Okay? Really, I punch it into Mathematica and let it worry about it. Everybody okay with that? Okay. So what did I do for the bottom, for this equation? This one right here. All I did was I did the cross product. Got it? Okay. So what's this next thing? Yeah, just solve for it. So what's the velocity of A? 0.8 minus 0.3 omega. All I need is omega. Boom, I got it. Right? How are you going to find omega? Yeah, so now you're going to do the yellow. I don't know why that little guy sits in there. Okay, so now I'm going to focus on the P equation. Okay, what did I do for step 1? Yeah, so P was a negative 4, Q was a positive 8. Yep. Anybody have an issue with that? You could do it? Okay. Tell you what, this problem does not ask you for acceleration, but find acceleration. How would you do it? Here's what I would do. I'd count the degree of freedom. Did it change? No. I'd count the number of special points. Did it change? No. How many equations am I going to have? 4. I'm going to write the same equations I wrote before. What's going to change here? Instead of VP equals VC, what am I going to write? AP equals AC, right? And I think it said that the racks were moving at constant speed. I'm not sure, but they would have to tell me a couple of double dot terms, or else I can't do it. Okay? I think it said this rotating at constant speed. Let's see. Well, it didn't say that, but I'm going to on an exam I'll say, okay, they're moving at constant speeds. Okay, I just told you 2 double dots. Okay, so the acceleration of P equals acceleration of C, and what's the acceleration of C? 0. Very good. Right? Because it's moving at constant speed. What if I try to trick you and say he's accelerating to the right at 2 meters per second squared? What would it be here? Positive or negative? Positive 2I. So I can't fool you. Even if it's not constant, I can't fool you, right? Is everybody right with that? Okay. How do you know that those 2 accelerations are the same? So do you still agree? The acceleration of C is, or what is it? Yeah, the acceleration of C is horizontal. What about P? What kind of contact you got? Temporary? No slip? Tell me about the acceleration. Are they the same? Are they? Only in the plane. Oh, crud. Ooh. Then what changes here? Velocity of P, or acceleration of P, right? Let's see. Let's put it in blue. Make sure that we don't get it confused. The acceleration of P equals, does it equal the acceleration of C? Okay, it's equal to the acceleration of C horizontally. Let's see. How would I write this? Okay, plus some double dot in the J. Right? What's the plane direction? Let me back up. What's the plane direction? Horizontal? Okay, so the accelerations horizontal are the same. Right? So what's the acceleration vertically? Is it the same? No? Okay. So you have an extra vertical component. Right? Okay. Now, how's that going to, what's going to happen? Well, down here, if you notice, when you do your cross products, all that J stuff is going to disappear. Okay? Do it this way. Let's say that these guys are moving at constant speed. Try to find the acceleration. On Wednesday, I'll show you what it is. Okay? So that's the only thing that's going to change. Well, also this equation, the Q. The equation for Q, this one. Because they're temporary contact, no slip. So what do you know? Well, horizontally, it's the same as B. Vertically, nah, I don't know anything about it. Okay, try that, see what happens. You want to do another problem? Okay. Okay, how about something like this? Let's see if I have one that's okay, how about this one? How about y'all do this one? I'll enlarge it so you can see it a little bit. Okay, if the gear rotates with an angular velocity of 10 and the gear rack moves at 5, determine the velocity of the slider block A at the instant shown. Okay, how are you going to do this? How do you know special points? Let's back up, make sure it's a Chapter 16 problem. Okay, so we're going to start from the very beginning. You know it is, but okay. On the exam, how do you know it's a Chapter 16 problem? What are you going to do first? What's the first thing you did that you wrote in your notes today? Step 1, count the degree of freedom. What's the degree of freedom? Can something move? You see what's happening, right? You got this rack just like before, and it's wiggling back and forth. Let me see if I can get my highlighter up, right? So this rack right here is moving back and forth, right? So it's moving. So that's 1 degree of freedom. Stop him. Can anything move? Yeah, because this gear, this pinion, or whatever it's called, can rotate. Can't it? Right? It can roll along on the rack. Okay, that's 2. Stop the guy from rotating. He now can't rotate. Can anything move? Yes, this guy is in a slider. This thing here is a slider. So it's in a, like a, you know anything about engines? Okay, you got a cylinder. This is a cylinder here. Right, this is a cylinder, a round hole, and then the stopper's inside moving up and down. So it's a piston cylinder. So yeah, it can slide up and down. Okay. So the rack is 1. You stop the rack and count 1, and then the pinion or the gear or whatever can roll along. So that's 2. Stop him from turning. Beg your pardon? Yes, it can, because there's a hinge right here. And there's a hinge right there. But if they were bolted on, then yeah, there's only 1 degree of freedom. In fact, there may not be any. No, there'd be 1. Okay. But yeah, those things can pivot. It's hard to see, I know, but in real life engineering, you go look at it and say, oh yeah, I can see, yeah, they're hinged. Okay. Okay, so the thing can turn. Stop, that's 2. Stop it from turning. Can anything move now? It's kind of locked down, right? Okay, what's the degree of freedom? 2. How many single dot terms did they give you? 2. What are they? Omega and the VC. So they've given you 2 single dot terms. What does that mean? You can find any single dot term you want. No free bodies needed. You can find any single dot term you want. What do you want? Velocity. You want a dot of A. Okay? By the way, you have to have, in order to know where A is, you got to know 2 positions. Do you know 2 positions? Yeah, so you know this guy and you know 60 degrees, right? So I think I've got everything I need for that one. Okay, so how are you going to do it? Okay, so it's a chapter 16, no free body needed. We're going to do, now, what are the ways you have of finding velocities? Ropes, cancel it out. Chapter 12, is it a time spanner? Forget about it. Let's see, loops. Special points. Okay? Can you find a loop? What's the loop? Let's call this guy right down here so we can all talk about him. We're going to call this point right there. Whoops. Pick up the pen. Okay. This point right here, let's call him B. Is that okay? Is everybody okay with that? Okay. What other point do you want me to mark for you? A? Where's A? Okay, there. All right. There's A. Right down here? Like there? So you're going to do a loop around that triangle? Good, good. Good loop. Good loop. I won't argue with that. What about this gear? That's rolling. You got to get a loop on them, right? You got this guy, that's a body. You got this guy, that's a body. You got a loop on those bodies, right? Because you're going to go B to A to what do you want to call this? D. Okay, D. You're going to go B to A to D. Not a problem. You got this connecting rod. You got this straight line down. You got that. What about the gear? You didn't put a loop on the gear. If you don't put a loop on the gear, you're not going to have this omega. I need a loop on the gear. Am I confusing you? If I'm not confusing you, then put a loop on the gear and you're in business. I think I'm confusing you. So when you're confused about loops, what did I tell you should do? Special points. Special points work for anything, right? And so if you get confused, here's a rule of thumb, right? Write this one down. You got to get a loop on every body. If you don't, you're not going to get any information about that gear. It's turning, and your loop goes from here. Does that include anything that's happening with the gear? No, it's just the center. You don't have the rotation of the gear. You see that? So it's not like it's a bad loop. You're going to have another loop that include, right? So you would go maybe from the ground, something like that, up and then over and oh man. And remember, I told you, if you have a lot of temporary contacts, loops are confusing. And you got temporary contact in here, right? So what I would do is I'd say I'm going to use those special points. Okay? So now we're ready to start. You had a question?
So I was going to ask you, anytime there's a gear, we shouldn't use a loop? Or
whenever there is temporary contact, you're going to have a hard time using loops. It's not that there can't be done. It's just it's going to be mind-blowing. Because what you have to do is you got to somehow put a loop on the ground, and then it's just, oh man, it's just ugly. So try to avoid it. Whenever you have temporary contact, my suggestion is don't use a loop. Loops are great for a lot of problems because with the exception of gears and stuff like that, it's all permanent contact, usually. If you think about most mechanisms, right, you're usually in permanent contact. The only thing that is temporary is like gears. So whenever you're faced with, I guess a rule, if you're faced with a gear, don't, you can use loops, but I would advise not, okay? I think there's some others. Oh, here's one. That one's not too bad. You can use a loop for that one. Okay. Okay, so we've decided we're going to use special points. Everybody agree? You see how we kind of eliminated things? And the reason I eliminated a loop, bottom line, I eliminated a loop because I don't like temporary contact with loops. I just don't like them. If it rotates and it's got temporary contact, I do not like it. Make sense? Whether it makes sense or not, write it down. If it rotates and has temporary contact, I do not like loops. You don't like them either. Okay, so how are you going to do with special points?
Figure out.
Okay, so y'all figure them out. I'm going to give you a minute. You're going to tell me what the special points are. How many of y'all counting? I count 4 also. What are they? A, very good. Why is A special? You want to know something about it? You do know something about it. Does it have any horizontal velocity? Okay. It only needs 1 to be special. You know something about it. And what else?
Touching another body.
Touching the ground, and it's touching that the connecting rod. So it's special for 3 reasons. Okay, so A is special. What else is special? Center of the gear, that's what we call B, I believe, right? Why is B special? Because it's touching the connecting rod and the gear, and you know something about it. What do you know about it? It's moving horizontally. So there's, it's not touching A, the rod. It's touching the connecting rod and the gear. So it's, yeah, it's on this one, and it's on this one. Okay, so it's special for that reason, plus you know it's moving horizontally. Right? What is C? That's the rack, I think, if you read the problem. This is the gear, the rack moves with VC equals, right? So C is on the rack. So I'll draw it in here. So C is right there. There's C. Bless you. Okay. What other points are special? A, B, that's 2. You said there were 4. Okay, that little blue point that, you know, why is it? It's on the little it's on this little rotating gear, right? Why is it special? It touches more than one body. Okay, what do you want to call that? Well, I've got a D, so I'm going to call it a P. You can call it whatever you want. Okay, usually, I don't know why, but contacts are P's and Q's. I don't know. It's 30 years of doing the same thing over and over again. So you call it anything you want, it doesn't matter. It's special for only one reason I can think of, is touching more than one thing. Okay, but it's on the little rotating gear. Okay, what else is special? C, the way I've drawn it, I wouldn't call it C, right? It's got to be this guy right here. So we'll call him Q, is that all right? And Q and C are doing the same thing, aren't they? Because that was on the quiz, right? Q and C, right? The rack has got 0 here. So what did the quiz say? Oh, those velocities are the same, aren't they? Okay. So Q and C are doing the same thing. Right? Okay. Any other special points? Okay, I'm counting 4. How many equations are you going to write? 3. Pick up some partial credit. Write them. Write some. Bless you. So we all do the same thing. Give me a point that you're going to write between. 2 points you're going to write between. P and C, I'd say P and Q. P and Q. Okay, you had a question?
We're not using D anymore, right?
No, we're not. You want me to erase it? Yeah. Okay. Just to keep you happy, I'm going to erase it. Maybe. There's a little lag on the software, but okay, D's gone. It doesn't matter which one. You're going to write 3 equations, right? So write me 3 equations. Just so we keep them straight, P and Q looks like a good one because it's the contact stuff. So write the P and the Q. What do you know about P and Q? Okay, you're getting ahead of me, right? For those that are confused, it's temporary contact, no slip. What does the table say? It's not up there, but it should be in your notes. Velocities are the same. What is the velocity of Q? It's equal to minus 5I. So what is the velocity of P? Minus 5I. So you should write down velocity of P equals minus 5I. If this were the acceleration, then I would write, you want C to be accelerating? Give me a number for acceleration of C. Speeding up? We'll say speeding up at 2. So I would write acceleration of P equals minus 2I plus yj. I don't know why. Yj. Got it? Because it's temporary contact, no slip. Acceleration in the plane is the same as the acceleration of Q, which is horizontal 2. And if it's speeding up, then it'll be to the left.
Why is the acceleration 2 again?
Okay, let's make one up. Okay, so what I'm going to do is I'm going to say, just to get you ready, the acceleration of, the acceleration of C is speeding up at the amount of 2. Okay? Temporary contact, no slip, means that the Q and P have the same acceleration in the plane. So I would write acceleration of P equals, in the plane it's got the same as Q. What has Q got in the plane? Negative 2, right? So it's a negative 2I. What do you know about the vertical? Nothing. I'll just put a double dot just so you know it's an acceleration term. How's that? Okay. So if I were doing acceleration, I would do that. Now, what if the rack was moving at constant speed? What changes? Yeah, the negative 2 is a 0I plus y double dot. I don't know it. J. Right? Have faith. You write the 4 equations or 3 equations. It'll work out. You'll say, well, how in the world am I going to get y double dot? Try it. Show it. Do it. You'll see. It'll come out. Don't worry.
Do you have to have like acceleration that's going away? Because
It has to. This thing will be non-zero. If it's rotating, it will be non-zero. So what you'll do is,
like it will be just like impermanent contact.
yeah, if it wasn't accelerating this way and it had the same acceleration this way, they'd be in permanent contact. They would never leave because whatever Q does, P does the same thing, and they'll just ride right along with each other, and they'll be in permanent contact. It has to be non-zero, or else they will not separate. So if they're going to separate, it's got to be non-zero. Got to be. How are you going to solve for it? It looks like you're bringing in another unknown. It will work out. Trust me, it's going to work out. It will. Do it. We haven't done any yet, but do it. I'll do one Wednesday. Okay? Did y'all write the velocity of P? Got that in your notes, right? Now what? You're going to pick 2 more, right? Which ones you going to write? P and B? Why not Q and B? Yeah, pick them to be on the same body. It's easier, okay? So you could go from Q to B if you really are good, and I'm not saying you're not, okay? But pick P to B. So write the equation for P to B. Do you want to start with B or start with P? Makes no difference to me. The B or the P? B? Okay. Write it, B, start with the B. VB equals. VB equals. What's the other point you're going to use? B and what?
P.
P? Okay. VB equals VP. Very good. Which omega? Omega the connecting rod, correct? No.
Oh, no,
What
sorry.
omega? The gear. The gear. Why the gear? That's the one the points are on. The gear. Omega gear. Omega gear. Cross what? Yeah, so we're going to write VB equals VP plus omega gear cross R what? Give me some numbers and some I's and J's. You're going from J. It's going up? Is it going up or going down? Why? 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 Because it's always from the guy on the right to the guy on the left. That's why. Don't let me fool you. Right? It's from the guy on the right. Everybody know what right is? Guy on the right to the guy on the left. So it starts on P and it goes to B. Right? Okay? P to B. Where's P? Down here? Where's B? So is it up or down? Up. Don't let me fool you. Okay, so I'm going to put in, what's the number? Well, let's do it in millimeters, okay? Everybody okay with millimeters? 75 J. Give me the number you're going to put in for omega gear. Positive or negative? Okay. Take your right hand, curl your fingers in a natural way. Move them in the direction of this omega. Which way is your thumb going? Into the board. I call into the board negative. Okay? So that's a minus 10K. It goes in there for the omega. Everybody okay with that? Now, by the way, you may not choose I, right, J up, and K in. You can't do that. You must always choose a right-handed coordinate system. You can choose your I any way you want. You can pick your J any perpendicular that you want, any perpendicular. But the K has got to be a right-hand rule. You've got to go from I with your fingers, curl them towards J, and the K has to go in the direction of your thumb. Okay, has to. Otherwise, everything will be negative, negative, negative. All right? Is that clear? So, I right, J up, K out. Okay. All right, so now you're gonna plug in there. That's the second equation. Where's your third equation? Okay, between where? A and B. Why? Okay, because it's really only two left, right? And also, always pick your points to be on the same body. That's why I don't go from A to P. Not that you can't, but it just brings in more complicated stuff. Don't do it. So I'm going to pick between A and B. Do you want to start with A or do you want to start with B? A? Okay, write it. VA equals. See how boring this is? You should be falling asleep. You are. Not because you're sleepy, because it's boring. It's the same thing. There's no reason you should be making, unless you make a stupid mistake and say, oh, yeah, it was a negative. Right? Yeah.
Where are we doing in millimeters?
You can put it in meters if you want. Put your angles in radians, seconds. If you don't want to worry about units, put everything in radians, seconds, meters, kilograms, newtons, and then don't worry about it. Otherwise, you have to watch out for your units. Okay. Somebody have a question or? 8:45, so we got about 3 or 4 minutes.
Will it be the same omega? Or the
Will it be the same omega? What body are they on? On the rod. It should be the omega of the rod. It's not the same. Now, you could be saying, hey, look, man, I'm an engineer, and I know, and for some reason I know that it's 10. Do you? Is there Newton's fifth law that says, yeah, the omegas are the same? Not that I know of. So I'm not saying that you don't have insight, because you might say, well, yeah, because this one is the same length as that guy, that these guys have to be rotated. Oh, okay, you're on your own, man. Right? I'm not saying you can't do that. I'm just saying be careful. Right? The formula says it's omega of the link, and you can solve for it. So why don't you just do it and then say, ha ha, it's 10, man, I'm good. Ooh. Do that rather than say it's 10, because if you're wrong, all your numbers are wrong. Because you're wrong. You put in the wrong number. You see? I'm not saying don't ever use your intuition. I'm just saying you be careful when you do. Because quite often you're wrong. Okay, we have 2 minutes. So let's write it real quick like, okay, velocity of A equals velocity of B plus omega of the link. I think the link is going this way. I'm going to call it omega L. What am I going to plug in? Plus or minus omega L? I'm going to do this, right? Out of the page, plus. So I'm going to put in plus omega L K cross what? From where to where? From B to A. So I'm going to go left, and that looks like that would be 0.5 cosine 60. Let's do it in millimeters, right? Oh, that's a meter. Okay, 500 then. Okay, so it'd be 500 minus 500 cosine of 60 left, so it's negative I. And then it goes up. Plus 500 sine 60 up. It'll come out in radians per second.
Why are you doing 500?
Because it's half a meter. Oh, crud. Right, 50. Okay, 50. 50. It didn't pick up my eraser. Okay, so it's 50. See, that's the reason you should make less than 100 on the exam, because you put in 500s to Stop it. All of you. You're making an idiot out of me. Okay, whatever. Omega cross. Okay, now how many unknowns are there? What are they? What are the unknowns? Let's see, I didn't write my P, right? Velocity of P equals, what's the velocity of P? Minus 5?
yeah, and that's gonna be in meters per second.
Okay, then I got a unit problem. Okay, but what are the unknowns? I know P, right? So I know P. So I know this guy completely. I'm going to take that and put it in here. Right? Any unknowns in here? What's unknown there? VB? You got an I and a J maybe. You got it? So the second equation is going to tell me what B is doing. Okay, I'm going to take that and I'm going to put it in here. How many unknowns are there? What are they? VA? I and J? I and J? And omega? 3. Uh-oh. I've only got an I equal I and a J equal J. There's got to be something else known. How do you know that? It's going straight up and down. So the velocity of A is what? Velocity of A is straight up and down. Let's call that DJ. Isn't that true?
Yes.
Okay, now how many unknowns? 4. I've got the VAI, VB, right? VAJ, and omega. But I've got an I equal an I, and an I equal an I, J equal J, J equal J. So it's working out. Oh, I know what you only got 2, because you say you got okay, you're going to take this. Let me back it up. I think that's it. You're going to take this guy right here. You're going to put him in right there. Now you got 2. Has that worked for you? Okay. And you're going to set I equal to the I, the J equal to the J. You're going to solve for the two unknowns. Bang, you got it. Problem solved. You just did your first problem. Or maybe you did more. Maybe you've been doing VA equals what? Why is it only a J? Oh, did I use a D somewhere? It's only vertical. It's only vertical. That's what I'm saying. It's only vertical.